Okay, hello everyone. Thanks for coming here. I'm Luca Marturana. I work at Sysdig. I'm as a software engineer. I work on the Sysdig open source tool, which is the argument of the conversation today, and on our commercial instrumentation agent for cloud infrastructure. I have a previous experience as a backend engineer, and I hold a master degree in computer science. What's the agenda of today? We will see the common troubleshooting workflow, common tools used for troubleshooting. We will introduce Sysdig, which is our open source tool, and we will see a little bit how you can leverage Sysdig for your own troubleshooting needs. And then we will see a sneak peek of Sysdig Cloud, which is our infrastructure tool as a service. First of all, we start with the troubleshooting workflow. Usually we have our application deployed on cloud servers, and the first thing we do to troubleshoot is using SSH to get inside our server, and we use, for example, top to see which process are running on. You see the something of the screen, or it's okay? Okay. We use the top, for example, to see the process, if some process is running too much CPU or too much memory, things like that. But as we can see, top doesn't play well with containers. Right now I have some containers running, but here I can see any information about the containers. One thing that you can do with top is visualizing the C group, which is the information right here. C group is one of the kernel facility used by Docker to build containers, and but from the C group you can understand, for example, here that those processes are inside some container, but you can't get easily the container name or container image, things like that, which are Docker related metadata. Another thing, if we want to use netstat, for example, to see actual connection, we can see here, for example, I have a Redis container. I don't see the port of Redis, which is 6379. I can see it. This happens because containers use another feature of the kernel called namespaces. Namespaces is a feature that kernel provides to split resources inside your processes. So a container sees only a slice of the resource of the system. For example, each container has its own network stack with its own network addresses and so on. So I can see the Redis activity here. I can use, for example, Docker exec. With Docker exec, I run netstat inside the container Redis, and here I can see the port where Redis is listening. Same happens with, for example, tcpdump. But tcpdump didn't work because I don't have in the Redis container tcpdump, and it's normal because we want a container to be very lightweight, very simple. I don't need tcpdump to run Redis, so I don't want to install tcpdump on my containers. But to troubleshoot Redis connection, I need tcpdump to see what's going on. In this case, with a little tricks, we can do this. For example, the namespaces used by containers are network namespace, file system namespace, user namespace, and another one, and other ones. We can just enter the network namespace of Redis and use the tcpdump utility from the host. We can use a simple utility called nsenter. Applying to use nsenter, we need the process ID of Redis, so we can use nsenter. Okay, so using nsenter, I say to the kernel, bring me to the network namespace of this speed and launch my tool. So here I can see there is some traffic on the Redis container, but you know, it's a bit, it's not a straightforward workflow. So seeing inside the containers is not easy, because containers are isolated. They have their own set of resources. They are self-contained. They have what they need inside everything. They are simple, so I don't want to install a whole operating system set of utilities inside my containers, because they should be lightweight and easy to use. So can we do something to get monitoring troubleshooting, which we need them to deploy containers and use them effectively in production, without leaving those properties of the containers. This is what we are doing at Sysdig with our open source tool Sysdig. Sysdig, so it's our open source tool built to monitor and troubleshoot containers. Comes with two interfaces, a command line interface and a cursus interface. I start from the cursus interface. Okay, launching Sysdig. Excuse me. We can see the view like top or htop, if you are familiar with htop. We are seeing the top processes. We can order order them by CPU usage, memory usage, and so on. We see the command line of the process, but we see also the container where the process is running, the container name. But we don't have only this view. We have, for example, containers view. In the container view, we see only a view of top containers running in our system. So all the resources, CPU, memory, network activity, and so on, are grouped by container. So we see all what's happening, what container is using how much resources. You can navigate your system. For example, if we go inside the Redis container, we see there is one process running inside this container, which is Redis. We can see the speed of the process and the activity of this process. We have other views, like, for example, server ports. In the server port view, we see the listening port. For example, here I can see the 6379 port, which is the port of Redis, and I can see how much activity is going on. Another view is the connections view. The connection view, I see all the connections. Right now we have only one. All the connections also running inside this container with the EP port and so on. We have another mode that we called echo mode, which is going here. Here we can see all the traffic of this connection, the connection that we selected. So all the data exchanged by Redis and the clients.
We're still inside htop now?
What? Excuse me?
Still inside htop?
Inside the Sysdig. It's not htop, it's Sysdig. Okay, sorry. Okay. Another thing we have, it's what we called the dig mode. Here we can see the whole set of syscalls that Redis is running on the operating system. So every activity that Redis does, it's traced by Sysdig, and so it's a very rich set of data, and we can, for example, here understand how Redis is working. For example, let's go here. Here we are seeing that Redis is using ePOL API, so it's using event-based I/O. Here is does a read, and it's reading a command. Then Redis writes the same command on a file, an append-only file. So Redis uses persistence in this way, writing a journal of all Redis commands given to the server, and after writes the response to the client, and we can read also the response. In fact, everything in Sysdig starts from here. We start from this set of data, all the events collected from every process inside the operating system, and on top of that, we can do all the visualizations that I showed you now.
What language is it implemented in?
Sysdig is written in C and C++. How it works? You have your applications, your containers, and the kernel, the operating system. We add a small kernel module that puts itself in the middle between the application and the operating system, tracing all the events happening. All this data is then collected by Sysdig, which you can run in its own container if you want, or in the as a host process. On top of Sysdig, you collect all these events. Sysdig enrich the information for each event. For example, on a write event, you find the file descriptor number and the buffer. Sysdig from the file descriptor number knows if it's a connection or is a file, everything, and put it on the event. Or from the PID, Sysdig knows the process name, process command line, container, and so on. So every event has a lot of interesting data inside. What Sysdig does is collecting system events. You can run a filter on top of this. For example, what we saw before to see the top processes, top connections, and so on. You can run scripts with this event. Scripts are written in Lua. We call them chisels. And we have the curses in the face they showed you before. And we support natively containers. Now I wanted to show you also how you can leverage Sysdig, how you can use Sysdig to fit your own troubleshooting workflow. What's the custom data you need to know from your system. For example, I showed you before that on Sysdig, we have, for example, running Sysdig, we can see all the syscall for every process, but sometimes you may need only the syscall of okay, you may need only what's running on containers, because if every process you need, you deploy this on containers, you don't need other process operating other process of the system. So you can filter using the container name, for example. And sometimes you may need only the network activity. So you can filter by SOC family in this case, and saying I want only the IP related events. So I can see, for example, there are some events from curl or Ruby and so on. But sometimes you want something more specific. For example, if you are debugging an HTTP issue, you just need what's going on the HTTP. You don't need the raw buffers. You need only the URL, response code, things like that. With Sysdig, you can build a chisel to do just this. Here we are. Here I built a chisel that prints the timestamp, container, and some data from an HTTP transaction going on. So I can see there are some get method used with some URLs and some response code. I'll show you actually how you can easily build something like that. Okay, the chisel API is just a script in Lua. You have to define some variables, so Sysdig can add information about the chisel on the command line. Then you can define some variables, some global variables to keep your state. Then you need mainly two functions. One is the onInit function, which is called by Sysdig when Sysdig starts. And mainly it's used by chisels to define a filter, because in a chisel you don't need every event of the operating system. You need maybe only network activity, only file activity, and so on. So it's better to filter so your chisel runs faster. Then you need maybe some feeds from the event. So you need to ask before Sysdig which fields you need. So Sysdig will export that data to Lua too. After that, you have to define the onEvent callback, which is called every time an event occurs. In this case, I get some feeds from the event. Then I have a bucket with the opened transactions, so all the requests coming to the network. If I don't find a transaction for this event, I try to parse the buffer if I find a request. If I find a request, I open a transaction and put it on a bucket. Then on another call of the onEvent, if I find a transaction opened for this connection, I try to parse a response. If I parse a response, I get some data from the response and then print the transaction. So it's pretty easy to do this kind of stuff. Just writing 100 lines of code in Lua, you can do your custom HTTP parser to see to log all your HTTP requests. And that's the output. On the output, you can print a lot of things, not just HTTP data, but also the container name or the process ID, timestamp, and so on. With a little bit of work, you can do, for example, another view, httptop, for example. This is httptop. When you see all the transaction going on, like the top process, but top HTTP connections with the container, method, URL, and so on. So this is how you can leverage Sysdig and build your own scripts to do your own troubleshooting. Finally, I want to show you a sneak peek of our cloud infrastructure tool, monitoring tool. We called it Sysdig Cloud. And again, it starts from Sysdig. All the events collected by Sysdig or from our agent, it's parsed, we get useful data from them, and then we send it to our backend when you can do some nice visualizations like this. Okay, I don't know if You can see something probably. Okay. Here you can see the list of your hosts that have Sysdig installed. You can group them by everything you want. From role to region, everything you need. You can see your containers. You can navigate from groups to host to container. You see the metrics from that container that where you go. This is different view. For example, system memory. Here we are seeing the memory of this container of this host and other top process, for example, and so on. Another nice visualization that we did is what we call the map. Here we can understand something about this infrastructure, demo infrastructure. We have some clients on the left, an elastic load balancer just on the right of them. Then we have some front-end servers, and we can zoom in to see what those front-end servers are doing. So we can zoom and see on those hosts what's running inside. So we can see there is some Tomcat, some Python, some containers called WordPress that we can go again inside, and we can see, for example, that those WordPress containers are running Apache inside. So it's like a Google map for your cloud infrastructure. Everything here, it starts from Sysdig events, what we collected on Sysdig. At Sysdig, we are trying to fill the gap between a common troubleshooting tool and the container world, which is a world with a lot of new stuff going inside. It's a very dynamic world. You have a bunch of hosts. You don't know before which application will run. Maybe are managed by a global scheduler, things like that. So all we build is very dynamic, and we are trying to get information from all containers to troubleshoot, to understand if they are working well or not. That's it. You can find me on my email address or some social networks. Thank you for listening.
Anybody got any questions? This gentleman here.
It looks interesting, but what's the performance impact of running software?
Sysdig, it's built to be production ready, so running production. The module that I showed you before has a lot of things to be very lightweight. So it just copy the smallest amount of data needed to do the tracing and get out of the way. Also, for example, if there are too much events, we drop event because we don't want to be a performance bottleneck for your applications, because it's not a good way to do things. So the module is very small, and we are working hard to keep the performance very, very good.
Yeah. Is it then running continuously, or is it running when you ask for kind of information?
Yeah, the Sysdig tool run when you run it, it works. So all the Sysdig views that I showed you are run when you exec the command. Our commercial tool works 24/7, and we do a lot of things to be lightweight. So we don't parse all events. We just we parse all the events we need, and so we do a lot of things to be lightweight to run 24/7. Also, another thing you can do with Sysdig is that you can just trace the information of the system when things happen. Then you can analyze it later on your computer, so you don't want to make too much noise on the server. So just you trace everything is happened. Then on your laptop with Mac, Windows, everything you want, you can run chisels, you can run Sysdig, so the curses interface, just after things happen. It's like you do with Wireshark or tools like that. Yes.
Yeah, so you have to install a kernel module for it to be able to record the data.
Yes.
But there's a whole bunch of OSs out there now that one of their main features is that you can't really install anything. You can just run stuff via Docker containers. So how would I use this on, say, Core OS, where you can't really install? There's no like apt-get, or there's no yum. There's no easy way to install something as a kernel module, for instance.
To install our kernel module, it's very easy. You have there are two ways. If you are a common operating system, a common distribution like Ubuntu or Debian, things like that, you can just install with one line of code. We have our script to install everything. If you have a Core OS, for example, which is a very lightweight operating system with nothing more than Docker, more or less, running inside, we have a pre-built list of kernel modules already compiled. So, for example, in Core OS, if you start our Sysdig container, just pulling it from Docker Hub, we start, find the correct pre-built module on our infrastructure, pull it and load it. So for a lot of tools we have already pre-built the kernel module.
Right. Earlier you mentioned that if there are too many events, you just drop them, right?
Yes.
So using your cloud infrastructure,
yes.
do you drop these events as well? Because otherwise, how will we know whether this event that you drop could be important to us? How do you determine when to drop this event?
Okay, there are two things of dropping, two ways. One thing happen, it's like an hard cap. When Sysdig, when the kernel module don't find enough space on the buffer to move data to the user layer, it drops data. But it happens very few times because it's just an hard cap. Usually our queue is enough for every traffic. On our 24/7 application, first of all, always we drop a lot of not useful events. For example, if you open a file or you are sending some data to the network, we collect them. But if you just are doing some operation with mutexes, for example, we drop already this event because we don't need them. And also we have some, if your traffic goes very high, we do a subsampling mode. So we drop, like for example, half of a second of event. We predict what metrics are. So subsampling. If you can have this all the data from all the sample, or you have half of the sample and multiply the result to have just to predict what's the full sample data, because it's for now it's the only way we found to be lightweight with a lot of events. But we are finding other ways to be more smart on this kind of sampling, to drop less event possible and our metric be as perfect as possible.
So is there a part in your timeline or your development timeline that will determine which event to drop. Let's just say I want to collect everything related to network, but
Yeah.
drop the rest. Is it something in your timeline?
We already do this in Sysdig.
Okay.
Yes, we do this already.
Any more questions? Yeah. When you're using the commercial cloud thingy,
Yeah.
how much network traffic are you sending?
It's almost 6 kilobyte per second per host. But it depends on what things you have. If you have a lot of containers, if you have a lot of traffic, for example, we parse HTTP traffic. So if you have a lot of HTTP traffic, you get a bit more. Depends on the load of the system, more or less.
Actually, I've got a question. Have you done anything with Mesos frameworks? Have you deployed this?
We did a lot of tests with CoreOS, but with Mesosphere already not. For sure, it's one thing that we want to do. So in the future, we will work with all this cloud orchestration of containers.
Okay, so Penny's company has specialists in Mesos frameworks. You can
Okay.
speak to him.
Okay, cool. Yeah, for sure.
I also work at the same company.
Okay.
Okay, well, I think a big round of applause to Luca. Really, really good talk. All right.
Thank you.